All right, this is 8.4 video notes. So if you haven't already, go ahead and grab this paper, the one that looks like the screen from the supply shelf before we get started. Okay, now that you have your paper, we're going to go ahead and define what's called an algebraic expression. Now we've talked about numerical expressions that have only numbers in them, but algebraic expressions have something called a variable inside them. So the official definition of an algebraic expression is it is an expression that contains one or more variables. Okay, now below this, where it says 2x plus 75, this is an example of an algebraic expression because it has numbers, an operation, and what's called a variable. Now our variable is our x. A variable is always going to be a letter. To me, X, A, B, C, any letter of the alphabet. Mostly it's X though, but it can be any letter. Okay, our variable X, a variable is a letter or symbol used to represent one or more unknown numbers. Okay, this is what a variable is. So that X can mean any number. We can call that X any number we want. The X is basically just a letter or a symbol that represents a number. Okay. All right, so our coefficient is the number in front of the variable is our coefficient. That's what we call that number. So the definition of a coefficient is it is the number that is multiplied by the variable. Okay, so a coefficient is the number that is multiplied by the variable. It has to be multiplied. If it's subtracted or added, it is not a coefficient. It's a completely different term. Because remember, a term is separated by an addition subtraction sign. So if it's multiplied, then like 2 times x, in this case, when the 2 and the x are touching each other, that means that they're multiplied. And so the coefficient is the number that is multiplied by the variable. Okay, the constant. The constant in an algebraic expression, you can have what's called a constant. A constant is a specific number whose value does not change. Okay. So constant is something that is not attached to a variable. It is all on its own. And so the 75 will not change. It doesn't change because it's just 75. But the x and the 2, they can change depending on what the x represents. Because the x can represent 2, it can represent 4, it can represent 5 gajillion, if you really want it to, that 2 is going to change. That term is going to change depending on what you plug into x. Okay. Now, we can use something called substitution. We can use substitution. Oops, my writing is a little bit large. To evaluate an algebraic expression. Okay, we can use substitution to evaluate an algebraic expression. Now, 2x plus 75, we cannot evaluate that expression if we don't know what x is. Okay, we have to leave it like that because we don't know what goes into x. So an example of using substitution is this one below. We have 2x plus 75. What is 2x plus 75 when x equals 10? Well, then we can just substitute 10 in where x is. So if x equals 10, then all we do is we just plug in x, which is 10, like this. So then we have 2 times 10, and then we add 75. 2 times 10 is 20, plus 75 is equal to 95. Now, a common mistake is that sometimes you might want to do 2 plus 10, okay, because the 2 and the x are right next to each other. Do not do this. No. If you see a 2 and an x next to each other like this, you multiply. You multiply. Always multiply.